representation of sets. Representation of sets. We have here one first method, it is roster form or tabular form, and the second is set builder form. Set builder form or rule form, or we can also known as rule method. Okay, now your roster form is representation of set. Representation of a set. All the elements of the set are written. All the elements of the set are written. All the elements of set are written and separated by commas within curly brackets. For example, set of natural numbers less than 5. Those are simply, we can get it as 1, 2, 3, 4. Okay, so like this we represent the set in the roster form. And the second is set builder form. In set builder form, the set is represented by a property, using a representative. For example, x says that x is a natural number less than 5. So like that, here x is a representative and x less than 5 is a property. So here in this method, in this set builder form, in this method, a set is described. A set is described using a properties of elements. Properties of elements. Representative. Okay. Generally here we can take the representative as x. For example, x says that x belongs to n and x less than 5. Here x is a representative. The properties are here x belongs to n and x less than 5. So like this we have to write the set builder form. That means here simply one is dependent on the other. That means if we give the if they give roster form, then we can convert it into the set builder form. If they give set builder form, then we can convert it into roster form. Okay. Now only we see that one, that is the set of natural numbers less than 5. So let us suppose this is a A. This one is a roster form. Then the set builder form is x is that x belongs to n, the property itself represented by x, and x less than 5. Here the representative is taken as x generally. So here these two forms are very important. So on this concept we have some important sums in 1 mark or 2 marks. So let us see them. very first one is here. Right roster forms. First one is X is a prime divisor of six. So here the set A is equal to, we have tried first of all divisors of 6, that means factors of 6. So factors of 6 are 1, 2, 3 and 6. So among these we need only the prime divisors. Prime divisors means prime numbers. So 2 and 3. So 2, 3. Okay. Prime numbers means a number which has only 2 divisors, that is 1 and itself. Here 2 has the only 2 divisors, 1 and 2, and 3 has only the 2 divisors, 1 and 3. Such type of numbers are prime numbers. So in this we have prime divisor of 6 means 2 and 3. So one is, we know that 1 is neither prime nor composite, and 6 is a composite number. So by that property you can write 2, 3 is the closure form of that. X is a prime divisor of 6. Here X is a representative. This representative describes one property, that is prime divisor of 6. So depending upon this, we have to convert this into closure form. And the second is X is a letter of geometry. X such that X is a letter of geometry. So here also simply write the letters present in this word geometry. So in this word we have E is 2 times. So by writing the set we write only 1 time. So let us see this one. First of all, the first letter is G, and the second letter is E, third letter is O, fourth letter is M, fifth letter is T, sixth R and Y. So while writing the objects or elements in that set, we have to write the alphabets. If they are given in alphabetical word, we have to write the alphabets in the small letters. Okay, and always these sets are always represented by the capital alphabets, capital letters. Okay, so just remember the point. Next, B is equal to X such that X square is equal to 4 and X belongs to Z. Okay, now first to solve this one, X square is equal to 4. So we can write it as X is equal to square root of 4. That is X is equal to plus or minus 2. That means plus 2 square is 4 and minus 2 square is also 4. That's why square root nothing but we have the 2 roots. 2 roots. Square means 2. Square root of 4 is 2 roots. So square root of 4 has the plus and the minus 2. So moreover they give the X belongs to Z. That's why the roster form of this one is simply minus 2 and 2. For example, if they give belongs to N, for example, if they give belongs to N, by writing the set here, simply write only 2. Because natural numbers, it doesn't have the negative numbers. Okay, so for this one, the question is like this. So if B X such that X square is equal to 4 and X belongs to N, whenever it is belongs to N, then the answer is X is equal to set of 2 only. Okay, whereas if it is belongs to Z, Z means here integers. The integer has negative numbers as well as the positive numbers. So that's why the set of this set builder form is, also form of this set builder form is minus 2 comma 2. Okay, so we have to, while doing this type of question, just keep concentrated on that property. Okay, and next one is X is that X is equal to n square minus 1, n belongs to n less than or equal to 6. So which are very, very important. Okay, these types they lost mainly. So here x is equal to n square minus 1, n belongs to n, that means all are natural numbers, and they are up to 6. That means we have to write xn is equal to 1, and then 3 and 4, 5 and 6. So at these values we have to find out that all x values which are represented by n square minus 1. So now first find n is equal to, or n is equal to 1 at x value. It is 1 square minus 1, 1 minus 1, 0. And next n is equal to 2. X is equal to 2 square minus 1, 2 square minus 1, that is 4 minus 1, 3. And next n is equal to 3, x is equal to 3 square minus 1, 9 minus 1, 8. N is equal to 4, that is x is equal to 4 square minus 1, that is 16 minus 1, 16 minus 1, 16 minus 1, that is 15. And next n is equal to 5, n is equal to 5 square minus 1, 25 minus 1, 24. The last value n is equal to 6, that is n is equal to 6 square minus 1, 36 minus 1, 35. So while writing here, here the elements are starting from where? 0, 3, 8, 15, 24 and 35. So now here the circular form of this one is, simply we can write it as set C is equal to, actually 0 does not belongs to n, but here the x is equal to n square minus 1. That's when we need to write the 0. Here start with 3, 8, 15, 24 and 35. 3, 8, 15, 24 and 35. Here you can take 0 also, but because here x is not represented in the natural numbers, so that's why here x is total x is n square minus 1. So you can take 0 also, 0, 3, 8, 15, 24 and 35. So these are the set builder form of that n less than or equal to 5. And the next one is connective question. It is connective means it is from the chapter actually body equations. It is linked to that of body equation. The solution set of equation x square plus x minus 2 equal to 0. So here we have tried the solution set of this one. So to that, first of all we have to factorize this equation by splitting middle term. So take the first term and last term, x square into minus 2 multiply it minus 2x square. Step 1. The step 2, here we have to get middle x, that is exactly 1x. To get 1x, that is the factors of 2. So especially the 2 factors simply what? 1, 2 is up. So that is here we have minus 2x square. Minus 2x square means here we have minus 1x and the other is 2x. Okay. So minus 1x, 2x, 2x minus 1x plus 1x, 2x into minus 1x minus 2x square. Those conditions must be satisfied. Here we can write it as x square minus 1x plus 2x minus 2 equal to 0. This is the method of the splitting middle term. So here we can write x square nothing but x into x minus 1 into x, 2 into x minus 2 into 1 equal to 0. Here we can take common x from these two, x common, x minus 1 plus 2 common, 2 into x minus 1 equal to 0. And again x minus 1 is common, x minus 1 into x plus 2 equal to 0. the product of two expressions is 0, then each expression is equal to 0. Then x minus 1 equal to 0, x plus 2 equal to 0. Here x is equal to 1 and x equal to minus 1. The set is simply minus 2, 1. So like this, they lost the circular form, the Roster form. So move to sums of it, simple sums. Simple sums here. The next one is x is that x is a prime number. X is that x is a prime number and divisor of 6. Divisor of 6. Already we see that one. So first let us see this one. X is that x is a prime divisor of 30. Prime divisor of 30. So first write the factors of 30. Factors of 30. 1, 2, 3, 5, 6, 10, 15 and 8. So among these we have to write only prime. Prime numbers are 2, 5, 2, 3, 5. 2, 3, 5. So singular form of that one is simply 2, 3, 5. Okay. So now next. X is that x is a odd natural number less than 10. X is that x is a odd natural number. Odd natural number less than 10. So here we can write odd natural numbers means start with 1 and 3, 5, 7 and 9. So odd numbers means a number which is not exactly divisible by 2 or a number which is divisible by 2 and leaves remainder 1 are known as the odd natural numbers. So here 1, 3, 5, 7 and which are less than 10. Okay. Already we asked natural numbers. Natural numbers are generally start with another form. So like this we have to write the what set builder form to Roster form. Okay. Next now here next method, next concept, write set builder forms. That means they give Roster forms to us, we have to write them into the set builder form. So this one is very important concept. So that's very important. Listen carefully. So the first one is write set builder forms. The first one is here. B is equal to set of -3, -2, -1, 0, 1 and 2. So this is the set actually set of integers only. X is that x belongs to z, but here x is the range. That means here it is start from -3 and end with 2. That's why in that case we have to write -3 less than or equal to x less than or equal to 2. And -3 less than or equal to x means what? -3 greater than means x greater than or equal to -3. X greater than or equal to -3. And already we have x less than or equal to 2. So by combination of these two conditions, you can write -3 less than or equal to x less than or equal to 2. So by saying only we can write easily. So now next second is 3, 6, 9, 12. Suppose let's see 3, 6, 9, 12. So by seeing this one, we have to observe the property present in it. That is, here it is simply 3 tables. 3 1s are, that is 3 multiples these are. 3 2s are, 3 3s are, 3 4s are. Okay. That is simply right here. X says that x is a multiple of 3. X is a multiple of 3 less than or equal to what? 12. Okay. Next. Follow this. 2, 4, 2, 4, 6, 8, 16, not 2, 4, 8, 2, 4, 8, 16, 32. So here also by observing this one, till it is 2 and 4 is 2 square, 8 is 2 cube, 16 is to 4, 4, 22 is to power 5. That is here, simply base is, keep it as it is, base is constant, and here 1, 2, 3, 4, 5 is the changeable. So that's why here we can write it as x such that x is equal to 2 to the power of n, where n belongs to n and n does not equal to 5. Okay. Here two forms, one is the exponent of 2 form. In that exponent, the n is belongs to the natural numbers and n does not equal to 5. That is the exponents all belongs to the natural numbers. They are up to the 5. So that's why here we write x is equal to 2 power n. This is actually exponent form. Okay, by practicing you can easily find out. So I will give this type of sums. So x is equal to 2 power n and n belongs to n does not equal to 5. Okay. Next, like this we have one more. 5, 25, 125, 625. So like this we have so many. You can write E is equal to 5, 25, 125, 625. So here is also each are kept in the form of exponent of 5. 5 power 1, 5 power 2, 5 power 3 and 5 power 4. Here the base is constant as usual. So here the builder form is x such that x is equal to 5 to the power of n. 5 to the power of n. Here n belongs to n and n up to the 4. Up to the 4. So like this we can write one more like this to practice purpose. For example, the set of f is 3, 9, 27, 81, 43. So here by saying this we can write simply 3 power 1, 3 square, 3 cube, 3 power 4 and 3 power 5. So all these are by getting find out reason. Already we know that process. So by that we also write in each number in the form of exponent of x. So again here x is such that x is equal to 3 power n and n belongs to n and n is up to 5, less than equal to 5. So like this we have to do the what? Separate the forms. And one more is there. One more is there. That is 1, 4, 9, 1, 4, 9, 25 up to so on 100. Okay. So what are these actually? There will be some CTA, then A is equal to, we can write 1 square, 2 square, 3 square, okay, one more is there, excuse me, 4 square, 5 square, up to so on 10 square. So the given numbers are all perfect square numbers. That's why here we can write x as that x is a perfect square number less than or equal to 100. So like this we can write the simpler forms. And one more is that A is equal to 1, 2, 3, 4 up to so 199. So here simply you can write x such that x belongs to n. Actually 1, 2, 3, 4. I'm starting with 1 nothing, but these are already nothing numbers. You know that one. X belongs to n, and these are strictly less than 100. X less than 100 or less than or equal to 99. You can write it. Now again, some set to b is equal to -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it is simple. Set to be equal to x such that the property is x belongs to z, the set of integers, and these are already -2, -3. We have so many on left side, but on right side 0, right side we have to 9. So that's why we can write x less than or equal to 9. Okay. So here represent here z is the integers. So that's why we're writing the integers. You may write from -2 or -3 up to so on left side. For example, we have to start with -4, dash dash dash, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 9 you must write. Okay. So like this type of sums of the set builder forms. Now the other concept is subsets of a given set. That means list out all subsets of the given set. So third model, write or list, write all subsets of set A equal to A, B, C, D. That means here subset means if A is a subset to B, for example, 2 is non-empty are there. If A is a subset to B means that every element of A belongs to the B. Then A is said to be subset of B. So here we have to write all subsets here. So we know that the empty set is always the subset to the given set, and the set itself A, B, C, D. The set itself is also a subset to the given set. Now by writing the subset, you have to write a arrangement type. So first of all, write the single-term sets. That is set A, set B, set C, set C, set D. Next, two elements starting with A, AB, AC, AD. Okay, and starting with B, BC, BD. Okay, and starting with C, CD, CA and CB. All are already there. CA and CB are already there. So now we try them. We have the different subsets. Now two elements are about. Now three elements arranged like this: A, B, starting with AB, A, B, C we have. And next, starting with AB, AB, D, AB, D. And next, starting with BC, B, C, D, B, C, D. And starting with CD, CDA, C, D, A. Okay. And starting with D, DAB. Already we have that one. So now let's write one. So here now count all the sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's enough. So by seeing the set itself only, we can find the number of subsets in that one. So here A, B, C, D is the number of elements. So how many number of elements are there? Number of A is equal to 4. Then the number of subsets of A is equal to simply 2 to the power of number of A. That is 2 to the power of A. This number of A is known as ordinal number. Ordinal number, as we all know that one. So if you know the ordinal number of the set, you find out that one, then we can easily find out the number of subsets. That is 2 power 4. 2 power 4 is here simply 16. So by seeing this set, we can immediately say that the number of the subsets of that given set. So we know that by knowing that 16 subsets, we can write all the subsets by just like within the arrangements. Okay. So like this we can